Hi, everyone. Welcome to the live stream talking about environmental engineering. My name is Amari Walker. I am in my 5th year of my PhD studying environmental engineering at Duke. We'll just see as people flow into the chat what questions you all may have about environmental engineering. But first, we will go to this presentation. So let's start here. Share. So now you should be seeing the questions that we'll be covering today, including whether you need to be good at math, what kind of communication skills you're going to need, also things like how, do we need to know how to code, what applications you're going to need to, can you even switch into environmental engineering, whether that is if you are still in college, or if you've graduated from college, or if you've even already done a master's or a PhD in something different. We'll talk about differences between different types of science majors compared to environmental engineering, if you'd like. And then we'll kind of finish it off with why do I love environmental engineering, and allow for any other questions that flow through the chat. I already see that there are a few on the chat already, but we will go through as many as we can in the time allotted. So first is, before we begin, you've probably come across my channel because either you've seen the videos that I've posted about environmental engineering, whether it's why you should major in this program, or why they're essential during a pandemic, to what does it mean to be a PhD in environmental engineering, and what kind of research do we do? What does that look like on a day-to-day basis, to differences between majors and minors. And so this is just another spur of those videos, because I've received quite a few comments of different questions related to environmental engineering. And so I wanted to open this up to everyone else to kind of put in a few of those questions, and then to just answer some of those to the larger audience as well. So first, I've separated a few of the questions that I've received over the past year into: one, what kind of skills do you need to be an environmental engineer? Two, what kinds of web applications do you need as an environmental engineer? And then three, how do you study? What does it take to really succeed and be a good environmental engineer, at least in a school setting? And then some of the differences between different disciplines, and then differences between whether you're doing a master's or you're doing a PhD after your undergraduate degree. And it's great to see everybody on the chat. So first question, what kind of skills do environmental engineers need? And before we even get there, let's just take it back a second, just to make sure everyone's on the same page. And I'll say that environmental engineering is the combination of multiple disciplines to work to protect and improve the health of humans and our environment. Whether that is if there are viruses in our water, to if there are emerging contaminants like perfluorinated chemicals that need to be cleaned up and removed from our water, or even the presence of things like microplastics, which I study and try to understand what their impact are, what's the impact of them in our water systems, or if we consume them. So, skills. Environmental engineering has quite a few different things going for it, but one thing that's going to always be very important is written and oral communication skills. You need to know how to explain your findings. You need to know how to, talk about the issue, whether that's as a consultant with the client or as a team, to handle these big issues, because we're working to protect our world, to protect our environment. Pardon me. You have to figure out how to work around that and communicate those findings. The next big skill is teamwork. almost everyone's going to be working as a group for almost any project that you get. You're not usually working by yourself for too much, unless you're doing, a PhD or something. But then, when you go into the work world, you're still going to be working as a team. And then being creative, coming up with really innovative solutions to these really difficult problems. I mean, even ideas like cleaning up these Superfund sites. You got to get creative on how to solve these problems that we have, because they're quite complex and they require, multiple disciplines of knowledge to come up with the right solutions, whether that's air quality, water quality, dealing with our hazardous waste, dealing with our normal waste, and the fact that we have increasing landfill capacity. How are we going to solve those big issues? Not only do we need to work on cleaning our air and our water, but we're also fighting this climate crisis and just rising water levels. And how do we combat that as environmental engineers? So that requires quite a bit of creativity. Next is the analytical and problem-solving skills. I've gotten quite a few questions on, do I need to be good at math, or do I need to even like math to be an environmental engineer? And I'll kind of share a little bit of my own story. I have never been, somebody who's been super crazy about math. There's some classes that I have enjoyed. I used to enjoy, like the early calculus classes, and then started taking some of the more difficult ones. And I had trouble. I had to retake multivariable calculus. I had to retake linear algebra, but I still did it. I mean, these were tough. They are tough classes as an engineer to have to do and accomplish to get to the next step, but they're still valid. They're still important. And no, I don't think you have to love every single aspect of the course, but you need to understand the applications of some of those formulas that are important for environmental engineering. So really, it's just about understanding what parts of the math are important for your discipline and are important for your job, because a lot of the stuff that you'll learn in these higher level math classes may not be applicable to what you do on a day-to-day basis. And when you're on the job, you're not, you don't have to remember things off of memory. Usually you can go look it up, figure it out, and there's usually some form of an Excel spreadsheet or a calculator that can help you through that process. But you do need to understand the basic principles behind some of these formulas that they're using for environmental engineering. And then you need to understand what kind of assumptions you can make to simplify them. And usually that just means that you're using the final derived formula. So you're not going to be deriving all the time. At least I don't. But understanding why people make those assumptions for whatever you're trying to answer in a bigger context. But for me, at least in my PhD, most of the work that I do now is still pretty simple math. I mean, maybe differential equations a little bit, but a lot of statistics. So I think one thing people don't think a lot about is usually they're worried about Fourier transforms or, Laplace, or those things are like really far out. I've never touched them since I've learned them. But things like understanding significance of a value that you get. Is the value of the concentration of this contaminant you find in water significantly different than what you have found somewhere else? And how can you compare these values amongst a sample group or population? And is it really different? And if it's different, how much so? And like what other variables come into play because this concentration is so high? So statistics, I think, is very important. And there are certain very important formulas that I think are also going to come into play. When I think of formulas, I think a lot about like air pollution formulas. That got nailed into my head, looking at the movement of gas plumes, those Gaussians. But there's nothing I've actually memorized to this point other than for the test. And then I don't have to really, I can pull it up whenever I need it. So other skills. But I guess to finish off the math question, you don't have to love it, but you do need to understand why certain formulas are important. You need to understand how to apply them. You need to understand how to make assumptions to make them simpler. And as far as being good at it, there are lives on the line. You have to become proficient at being able to apply these formulas and make the right assumptions, because this is you are being the steward for us, for the environment, for our water quality, for our air pollution, for solving our big waste issues. So these are things that are very important to get right. And so yes, you have to be good at the math that is required for handling these environmental engineering issues. It's not you need to be good at all math, it's you need to be good at the math that's important for environmental engineering. So I don't know if that made that more complicated for you or simpler, but look at those formulas that you commonly see, and just think about it, because there's not too many of them that come to my mind, that I think those are the ones that are like the main ones you really need to understand. Okay, so I've hit the nail on the head with math. And I think I just hit the nail on the head with understanding environmental engineering principles. So you need to understand there are quite a few different main formulas, whether that's like PV equals nRT, that's just normal chemistry. But there are a few that'll be very important throughout your career as an environmental engineer. Next. What web applications and tools do you need to be an environmental engineer? So first one, easy. If you are currently in high school or watching this video, just know Word and Excel will never leave. And you need to be very good at using both of them and learn all of the secret tools and knowledge. Basically read the manual back and forth on these, because they're not going to leave in the future, and you have to be proficient at Excel especially. Coding skills. So for coding, I already have a video on how to, do you need to know how to code? And it just depends on what kind of job you're doing as an environmental engineer, but more and more the field of STEM is including coding skills to be a very vital way of moving forward. We do a lot of work. I especially do a lot of work in our studio for visualizing my data, for doing statistical analysis of data. I've used MATLAB before. That was the main class that was taught at Berkeley for engineers, and I think it's also a very useful application, but it's usually used for different forms of modeling. It requires more of like a mathematical approach to utilizing that software. So I used it to model earthquakes and like simulate the movement of an entire state if it falls off the shelf. But that was for some earth and planetary science classes. So other coding softwares include Python, and even AutoCAD. I mean, it's not really coding. That's just another web application that people, can tend to use in consulting realms. But I don't use that one. But I know that is something that other, companies might look for in someone who's an environmental engineer. But for me, R is the main program that I do a lot of work in. So the other skills that people don't talk about as much are graphic design. The Affinity design is the one on the bottom, and then Adobe Illustrator on the top. Those can be really, really great for, visualizing, doing representations of your data, of making, whether that's a presentation for a conference or even making a figure of some kind. It's really interesting the level of graphic design can come into even engineering and in best modeling things. So it's not something that everyone is going to encourage you to do, but it's really handy to have a baseline understanding of how to use some of these programs, any of these programs. I don't use Adobe Illustrator. I personally use Affinity Design, but because I'm now more comfortable with using one of those platforms, I think it would be too challenging to switch to the other one. Just because it's really, it's been really helpful for me to make representative figures that best, represent my data, best represent the experiments that I'm working on, or even the sampling sites. So it's just a really good skill to just add to your repertoire, even if you're doing like website design and you want to make your own logo. That's pretty easy. Well, it takes a little bit of practice. I wouldn't say it's pretty easy, but once you get used to it, it makes it a lot easier for yourself. Next questions. How do you study? Well, there's a couple ways to think about this. One is just, straight up going through studying processes. You can do things like the Pomodoro technique, where you take 25 minutes at a time to do a task, and then you take 5-minute breaks in between until you reach the end of like 4 25-minute intervals, then you take a longer break. I've done that before. It's been helpful. I think it made me feel a little bit more refreshed. But I think my typical route is just to kind of push forward until things get done. So it just depends on you. It depends on how you best study. For tests, when I was still taking tests, I would usually study with the group, or even homework. I would talk through some of those formulas. I would talk through the routes to going about solving some of these problems. Because it is, I mean, it's a team sport in itself, learning how to be an environmental engineer. And usually there's always somebody else in the room that has a different, knowledge set that can help and complement yours. So I've taken the approach of just working with, as a team to understand these concepts. And then, when you get to test day, you finally will be able to understand it from multiple viewpoints, because you've worked and studied with multiple people at the same time. The other thing is just studying in general. One thing that I really highly encourage is, after every lecture, take the notes that you've written out and rewrite them. Whether that is, an hour later or a day later, it kind of doesn't matter. But as long as it's still somewhere around the same week, I think that makes a big difference in just reinforcing your knowledge and realizing where there's holes. I mean, it's just so easy to sit in a lecture and let the words fly over your head. But it's so important to be able to reinforce that by rewriting the entire lecture, and you'll be able to walk through some of those derivations. You'll be able to walk through some of those chemical transformations or understand those microbial processes, because it's just a complex number of courses that you're taking. There are various differences between them, but I think it's very important to reinforce knowledge by rewriting and color coding how you rewrite them. And that's, your own choice, whether you're adding in a specific color to ask questions about something that you just rewrote. Like maybe you forgot to finish a sentence and you need to ask the professor in the next lecture what that sentence meant. Or if you finally went through a mathematical derivation and there's something wrong with it and you need to ask for clarification. Those are important things to do, because when you go to office hours, which you should be going to in college, those are the things that you can bring up. And it feels a little less awkward if you're in office hours, if you at least have a few questions to talk about and bring up, than just to kind of sit there. But you should always go to office hours no matter what, see what other people are asking, get feedback, and just be present in the professor's eyes, because that's important for letters of recommendation if you want to go to grad school. Other studying techniques. I think that's the main one, working in groups, figuring out what works best for you, whether that's taking multiple breaks, and learning how to rewrite your notes to reinforce that knowledge. I typically, especially when I do things like study for the FE, which I took 2 years ago and passed the first time, I went through all of the handbook of the basic principles that were important. I rewrote out entirely brand new sets of notes to cover each section, highlighted the important formulas for each section, and then I went and took study practice problems based off of that information. So get your studying right and then do practice problems. And that's just my advice for studying. Next. And before I go any further, if you all have other questions that have come up, please feel free to put them in the chat or put them in the comments if you're watching this video later, because I can come back and answer them, or make a new video as well if you're later watching this video. Differences between other disciplines. So some of you all know that I started as a marine science major at UC Berkeley, so I was not doing engineering. And then sometime around my third or fourth year, I realized that I wanted to be an environmental engineer and that I wanted to kind of switch gears. And so I, at the time, thought that I needed, engineering level courses in the math and, just to get the basics down to be able to switch to environmental engineering for a master's or a PhD. So what I did was I ended up taking the, linear algebra, I took the calculus, I took the general engineering, course for coding, and then a few of the environmental engineering courses, just to get that background. And that was super helpful for me. I think it gave me a leg up when I decided to go into my graduate program. I think it made things a lot smoother for me for at least half of my classes. And then the other half, I had other really great cohort of colleagues that understood those concepts before, had learned those concepts before. And so we filled in each other's holes. So it worked out fine. But what I'll say is that quite a few of my colleagues came from other disciplines and had never gotten that same background. They had not taken the math classes that would be typically required. They had come from other disciplines of science, yes, but they were able to do fine. It was still a little bit of a learning curve, but we all supported each other through it, and we got through it. So you can absolutely come from a different major and decide that you want to get a graduate degree in environmental engineering, whether that's a master's where you're just taking coursework, a master's where you take coursework and do research and come out with a thesis of some kind, to getting a full PhD. You can totally be an entirely different major, including being a civil engineer. I see that was one of the questions posted earlier. A lot of my colleagues, not a lot, at least 2 or 3 of my colleagues came from a civil engineering before they switched to environmental engineering for their PhD. It is, it is a little bit different, but you already have the math qualifications for it. It's just picking up the chemistry and the biology, which can be a little bit of a tricky situation, but it's all doable. The biggest differences that I think I saw between my earth science degree and environmental engineering, I mean, we're all still problem solving. So I think there's quite a bit of similarities between the two. I think the level of making assumptions and simplifying formulas is quite different. I think the intention behind some of these problems is different. Like we're applying them to try and understand contamination. We're trying to understand how to remediate sites. We're trying to understand, why a bacteria grows so fast and can be a problem. So those actual applications of the science are entirely different versus, science just to understand science and be amazed by it, which I mean, I loved it. I mean, even for marine science, I guess some of it was a little bit geared towards climate change, but not entirely application based. The other differences, I've talked a little bit about, whether you should major or minor in environmental engineering, and you can go ahead and watch that video if you want to see some of those differences. But we can also talk about differences between graduate programs. So some of the other questions that I get emails and reached out to about is switching to graduate school, getting a master's or getting a PhD. And they say, how do you make yourself the best candidate for these environmental engineering programs? And it really depends on if you're trying to get a master's degree or a PhD. Pros and cons for master's versus PhD. I think the biggest one is the cost. If you're doing a master's degree, you are more likely to have to pay or take out loans. There's not as many scholarships available for master's degree programs. PhDs are usually fully funded and they give you some form of a stipend to live on. And depending on where you actually decide to do that PhD, that can be a very adequate living expense and realistic lifestyle. And then you come out debt free after 4 to 6 years. For, thinking about like whether that's right for you, that also depends on if you like research. And so if you've decided, okay, I don't want to pay off, I don't want to get loans anymore or at all, and I want to go ahead and just do this PhD program, well, you have to like research. That's if you don't like research, then you're going to have a troubling time doing a PhD, because that's what the main purpose is to understand and build knowledge from a very, very tiny sphere to apply to the realm of environmental engineering. So you'll spend a lot of time in the lab or doing modeling work, computer work, to understand the phenomena and add to the body of knowledge. So that's like one of the biggest pros or cons is, you have to like research to do a PhD, but PhD is fully paid. You don't have to, worry about tuition or anything else like that, no matter what school you go to. The other big difference is in, and I will actually full screen this now because I think that's all of my PowerPoint. Yes. The other big differences is for a master's program is in what is important for getting into those programs. I'm not on an admission committee, but things that are more valued, especially for if you're applying to a PhD program, would be your research experiences or your work experiences that you can apply the same skills that you would need to be able to be an independent researcher, an independent thinker. For a master's program, I would think that some of the more valued experiences are your coursework, are your scores to getting into those good programs. So really thinking about like where things are, what values are placed on different parts of the application. That may also determine whether you want to go into a master's or a PhD for environmental engineering. And then thinking about what kind of jobs you want at the end of the day for those kinds of degrees. Now, a bachelor's degree in environmental engineering is great. You can immediately get into the field. You can take your FE, you can eventually get your PE, and you are a professionally licensed environmental engineer. You are ready to advise people on remediation techniques. You are ready to oversee, the building of water treatment facilities and, all of those processes to clean up our water, clean up our air, and clean up our contaminated sites. So bachelor's degrees will automatically get you in the field. really making a decent amount of money. And I'd say people would be pretty happy because we're solving our problems. People who want to do a master's degree, that can help if you want to move up the ladder a little bit quicker. If you want to do slightly more complex problem solving, I think a master's can help. And even if you decided that you wanted to go into a different realm, like policy, I think that a master's degree can add a little bit more value for that purpose. Or if you are coming from a different discipline, whether that is a different science, or even, if you didn't previously major in science and you want to switch into engineering, getting a master's in environmental engineering is a great way to, segue into the field. And then you can do the same steps. You can get the FE, get the PE, and be on your way. So those are pretty good for those purposes, good for career-wise. If for a PhD, which I'm still myself figuring out because I'm working to graduate, the job applications or the job opportunities can be a little bit more narrow because a lot of the strictly environmental engineering positions are for bachelor's or master's. They don't typically want to hire a PhD. Pardon me. They don't typically want to hire a PhD if they already know that a bachelor's degree can do the same work. If they've already gotten their, their FE and their PE, they already know what they need to know to get the job done. PhDs are typically hired to do the more complex independent thinking, the more complex problem solving. They can be hired to do like working at national laboratories for research purposes in material designs. And they can be hired to things like think tanks, where you are basically surrounded by other PhDs in multiple fields of science and policy and engineering, and you're tasked together as a team to answer some of the greatest questions that we have and try and fix these large scale issues, whether that's something like climate change or handling our plastic pollution crisis. So doing that, working in the nonprofit realm. And so, yeah, you can definitely climb a different kind of ladder, but the same opportunities for work may be, a little different. They may not be as available as some of the things that a bachelor's would be able to do. But, it just depends because there will always be doors closing and opening. And just depending on what you want to do and what you're passionate about, you can always work your way into whatever makes the most sense for you career-wise. Let's exit that part. So the other big thing is questions from you all. And I'm going to just check real quick and see if you all have anything. Ooh, pause this. Ooh, there we go. If you all have any specific questions for environmental engineering, things that have come up for you or that you'd love to know more about, like maybe specific differences between environmental science and environmental engineering, I can talk about that. One thing that is different between environmental science and engineering is just that you can probably apply to the same job opportunities that an environmental scientist will be applying to. You just have a little bit more opportunities open to you as an engineer because you can apply to both engineering and environmental science jobs. I think that there is some level of it's just a different expertise, especially in the method of problem solving and analytical skills that you're working on. So yeah, I think the job opportunities are a little bit wider in some ways if you choose to do environmental engineering over environmental science. Going for horticulture. Horticulture is great too. I studied plant biology When I was first starting at UC Berkeley, that was my first research project, and it was evolutionary plant biology, and that was interesting. It was a great way for me to love research, but it took me a little bit of time to find my calling for studying plastic pollution and figuring out how to understand this huge issue. So, other questions. Let's see. There was, oh, okay, pull these up. We've talked about math. We've talked about communication skills. You definitely need to know how to talk to people. And we've talked through the best web applications for environmental engineers. How do you study? Can you switch into environmental engineering? Absolutely, yes. Master's versus PhD. We've talked about what kinds of things are most important for when you're applying to these graduate programs. So I think for a master's, some of the things that are more important are grades, the GRE, and your letters of recommendation. Your personal statement can make a big difference too. But for a master's, I think it's just a different rubric in some ways. For a PhD, it's really your letters of recommendation and your research experiences. And then if you don't have as many of those, it's your work experiences that can apply, that will be applied to you being an independent thinker and researcher. And so that's what you're going to lean on in your personal statement, is explaining how your work experiences will best complement your ability to be a PhD student and excel at their program. And the last question was, why do I love environmental engineering? And what are the pros and cons? I personally love environmental engineering because I feel like I can have an immediate impact on whether that is locally or globally on problems that are just large scale. Everywhere around this world, we have different levels of water quality issues. We have different persisting problems with our air pollution. And especially when you think about air, it's, some of it will stay regionally, but whatever we throw up there can end up on the other side of the world and then end up accumulating in the bodies of places where they never even polluted in the first place. So there's a huge environmental justice aspect to this. The fact that there are, so many Western countries polluting our air and our water that can have really harmful impacts on the rest of the world, to just even our own hometowns or places where they had no idea that they were, living near these chemical factories or landfills, to even like recycling plants that can be releasing toxic chemicals into our air, into our water, and consuming. And so being a part of coming up with solutions for that, even identifying that there's a problem, which is sometimes half the battle for environmental engineers, is showing the world, showing government, showing the community that there is an injustice occurring in their air and their water, and being a part of the team to work on remediating that and removing that or minimizing its impact, which can be also very challenging. And that's where that, like I said, the math skills come in to being very necessary, along with your communication skills, being able to negotiate with different clients that have different needs to solving these problems. And so I think that is the biggest reason why I really love being an environmental engineer, because we're here to fight for us as people. We're here to fight for our environment, because anything that happens in our environment is likely to have a cascading effect on us as well. And so being stewards in that way to protecting our air and our water, and even preventing waste from moving too far, or minimizing it, is something, some of the reasons why I love it so much. Things that I don't enjoy would be I mean, the larger scale reality of the work that I'm doing is always one of the reasons why I remind myself when things get tough, this is what I'm doing it for. But when you're really in it, in the reality of it, sometimes that can be a little disconcerting. So things like wastewater plants. I'm not a wastewater scientist, but there have been occasions where I've had to study septic tank samples, and those weren't fun, or even do field work. I'm much more benchtop chemist, so going out to different parts of the country or different parts of the state to get samples for analysis can be exciting for some. For me, I prefer to already have the sample or make my own samples to understand and analyze. So those are things that, they have larger impacts, larger scale impacts. And so those are things I have to remind myself of, but the reality of doing them can be difficult for me. But it's all about the context of why we do these things. So that's a few of the pros and cons. There are always certain classes that had come up that I did not enjoy as much. One of them being physical chemistry, because it was a lot of derivation. And it was a lot of math that I was not as, it was not as easy for me to follow along. But now that I'm working on applying some of those tools, some of those formulas, I have a larger appreciation for them. But there's some things that I won't enjoy as much. But that's one of the classes that I did not enjoy as much. I'm a chemist, so my preference is always chemistry. So my favorite classes were looking at where do chemicals go in our environment. If you dump, toxic chemical X into the water, is it likely to go into our sediment? Is it likely to attach to our skin, absorb to our skin, enter our bloodstream, and then accumulate in our liver or different parts of our tissue? Will it go to the placenta of a pregnant mother? Or will it be likely to vaporize into our air and stay there, or just stay in our water? Those questions of where do these contaminants go, whether they're super toxic or not, are things that really are the reason why I enjoy environmental engineering. The other aspect of that chemical question is what happens to it in those environments. If it's in water, what are the properties of that water, and does that change the chemical? Does it make it more harmful? Is it more toxic now? And so those were the classes that I just really enjoyed, and one of the reasons why that's the work that I do as a PhD is because of that larger scale question of like what's going on with these chemicals. So the other question that's come up is, what about time management? Do you have to do a lot in a short time frame? It really depends. So when I was taking classes full time for the first year or two of my PhD, that's what I would count as my master's portion of the program. I would say that it was a little bit of time management for coursework, just to stay on top of all the homework and the tests. And so being really organized with those deadlines, and then fitting in extracurriculars, because I think those are always important to teach you the leadership skills, teach you the communication skills that you need, and even teamwork. So I think those are really strong things to add into your life. And that's where the time management really came into play when I was taking a lot of classes. When I've switched into the research realm, and sometimes research and classes at the same time, that is when I really had to be good at project management, at time management, and doing a lot of things at once, with sometimes really spur of the moment short deadlines. because sometimes things happen with research where, you're doing a timed experiment, something goes wrong, or you have something else that needs to be done immediately after. And so you may not have planned for that, but now you have to wrap that into whatever else is on your schedule. So having good time management skills is absolutely important, especially as an environmental engineer. And I think, depending on what kind of work you do, if you're doing consulting or if you are a facilities engineer as an environmental engineer, that is where things can be difficult if you work at a facility that works 24/7. As part of your profession, have you worked with Native nations regarding their drinking water or lands? I have not personally worked with their drinking water. What I've done before is I've gone on expeditions throughout North Carolina to get water samples from drinking water treatment plants, whether that's their wells or their reservoirs of some kind. And that's because our lab was looking for these perfluorinated compounds, these really long carbon chains that have fluorines on them, and they're just everywhere. They're in about 99% of all human blood at this point, and they're a man-made chemical that was produced, I think, probably 40 years ago, and is on everything. Like if you see Teflon, that is a PFAS compound. So we were looking for that in those water samples, and I don't believe there was any native lands at the places that I went to get water samples from. But the other place that I've done water sampling is in another location, North Carolina, which was predominantly Black and low-income community, just to understand their well water in comparison to municipal water, and just do a characterization of their water quality. And that's a publication that we're currently working on. It's in review. So when it gets published, I will be happy to share that as well. And so that one was a big environmental justice issue, but it was really just talking about the science. It was not addressing the environmental justice at all. So it was just purely from a scientific perspective of these water samples. I recently watched a documentary on Chernobyl and the radioactive pollution. Radioactive pollution. Some people deal with radioactive waste. I have not encountered anybody in my program that does that kind of work. We do work with radioactive elements. I think our lab was zoned for it, but I haven't really had to do that as much. I think it's become less of an outstanding issue right now for environmental engineers, at least for funding and research purposes. Do you collaborate with other engineering disciplines? There are definitely opportunities to do that. One of the first things I thought of is that there's this project to map the ocean floor, and that's one with multiple different kinds of engineers. Right now, I personally don't work with a variety of engineers. I'm mainly just doing chemistry, but I think if I had found a material science engineer that was a good fit, I probably would have added them to my group of professors, because I do a lot of study of polymers and how they break apart and how they're designed. So I think working with a material science engineer would have made a lot of sense. The closest I've had with chemical engineers is that quite a few of the other people in my discipline were chemical engineers. And so they've used their knowledge base to kind of help them in the realm of environmental engineering. I've worked in mechanical engineering labs where they have certain instrumentation that's been very important for me, including a thermogravimetric analysis. Well, I think mine was a DSC. It was a differential scanning kilometer. And so that's really just where you have two different samples and you heat them from I remember what the temperature was, like -60 to like 1,000 degrees or something. And you watch how the sample starts to melt and vaporize, and you measure the tiniest change in weight over that time span of heating. And that tells you information about the entropy of the sample. It tells you about the crystallinity of the sample. And so, yeah, those are just like material science properties for things like my plastic samples. And that was important in the mechanical engineering lab. Electrical, there's not as much overlap, which is where, like, if you're switching from electrical to environmental, that can be kind of an issue or a little bit more challenging, but still same principles. You have math background, it's a lot easier to do that. But if you're doing something like building a water sensor, that is where I could see multiple fields working together, like electrical engineering, like mechanical engineering, because you're going to need a lot of different fields to put together something that can test water for whether that is its temperature, pH, salinity, dissolved oxygen content, or other chemical contaminants, whatever that sensor is built for. That is where I see a lot of interdisciplinary engineering fields working together. Other areas. I think that's like one of the main ones that comes to mind is like water or air quality sensors would make a lot of sense for collaborating, or even just working in a think tank with other engineering PhDs to solve big policy issues or big worldwide issues. That would also make sense for me if that was fields of engineering collaborating. Anything else? I see that we've got probably about a few minutes left. If you all have other questions, I see. I also watched Chernobyl. It was great. Oh, curious. Okay, so what are the major obstacles that environmental engineers face in the work field? That depends. I think. Thank you. Of course, yeah. Let me think a little bit on this. Major obstacles. I think when I was in the field trying to get samples, it was just getting buy-in from whatever community that I was trying to get those samples from, and helping them understand what it's for. So engaging with people to understand why we're doing what we're doing, because there can be a lot of distrust in that. Like, my water has been fine this whole time until you went and looked at it and touched it, or the government's out to get me, or like some weird, difficult issues where you have to be the most professional you can be, and explain to them the science behind why you're doing what you're doing and how it is going to help them, and make sure that you're able to guarantee that they will have access to that information to empower themselves to decide whatever they want to do with it, versus just taking. So that can be a major obstacle when you are getting samples. The other issues can always just be if you're trying to sample random remote areas, that's just, field sampling life, that can be an obstacle. Analysis of those samples is also what I would say can be a huge obstacle, because that's the problem with the environment, is that it's complex and sometimes it doesn't make a lot of sense. So getting enough replicates and making sure that you don't have contamination throughout the process when you're analyzing samples, to making sure that you have enough samples from the area that you're looking at to make sense of spatial differences. That is definitely a big obstacle. And then the other one is communicating those results to whether that's the community to make a change, or even to, larger government bodies to say, like, this is the science, these are the legal limits, this is what it is. You can all move forward with this, or there are no limitations to what we've measured because the government has no regulations for it. But that is up to y'all to make that decision. And here's the current science that we have about this contaminant. And so that's where it can be difficult to try and communicate those results without, being biased about the data and what you know, and just stating what the current scientific facts are in the field today, because those facts can change overnight. There are always new studies published that can entirely transform the field. So science is always a lot of weird probability in some ways, and not being 100% sure about something, but saying that, we have this amount of confidence in this answer and with these assumptions in mind. So being able to just professionally talk about what your findings are and communicate them in a way that people can understand. I think that is something that can be a challenge for people, but you gotta do it, you gotta practice, and you'll get better over time. Oh, thank you. Yeah, thank you all for joining. And this recording will be saved on my channel for anybody who else wants to watch it. Again, my YouTube channel talks about quite a variety of things, including environmental engineering, but also plastic pollution solutions to chemicals in our everyday products. And if you have any products that you would like me to review and talk about the chemicals reported on them and why we should be more careful about what we're using and think more sustainable, I'm happy to do a review on those as well. The other aspects of my channel, they'll be changing a little bit. I'll still be talking about microplastics and plastic because that's what I do, and working on finishing my PhD and graduating. So videos may be a little bit sporadic, a little bit slower over these next few months, but I'm going to do my best to try and get some of the interesting tidbits out to you all. And yeah, don't forget to watch any of the other playlists that I have for environmental engineering, for plastic pollution, or even for college if you have questions about graduate school or undergrad in succeeding. So thank you all, and until next time. All right.